All right, so here we have one where you have two logs on one side and no log on the other side. It's really nice and convenient when there's just the log with the same base on each side, and we can just use this little handy property, but we can't. So the first step that I'm gonna do is, before I perform the inverse operation of log base 4 of something, I'm going to condense the left side so that I only have one log to take the inverse of. Log base 4 of 3 times negative 4x equals 1. Okay, so the sum can be turned into a product. Of course, you can actually simplify that, so let's do it. Log base 4 of negative 12x. And this is where we get to the somewhat tricky part. As you can tell, I made a mistake earlier. So, to undo a logarithm, the inverse of it is exponential. So remember, when we were up here, we were doing log base, the same base as the exponent, and that was how we were able to take x plus 7 out of the exponent and make it regular script. I call it, because the exponent is postscript. Okay, regular script. Now, you have a log, it's in regular script. Now you need to turn it into postscript, this one into postscript. Both sides, you have to do whatever you do to both sides. So the inverse of log base 4 of something is putting that into an exponent and the base of that exponent being the same as the base of the log. So this is what I'm talking about. The base of the log is 4, so the base of the exponent will also be 4. Four to the power of the left side of the equation is equal to 4 to the power of the right side of the equation. So the left side goes into the exponent, and the right side goes into this exponent. 4 to the power of log base 4 of something is simply that something, okay? That's an inverse operation. 4 to the power of log base 4 of something leaves us with negative 12x is equal to, you still have to take this side, okay? 4 to the power of 1, that is 4. X is equal to negative 1 over 3, right? When you divide both sides by negative 12. And I do need to check that that would work. There's only one input for it. Negative 1/3 times negative 4. That's not 0 or negative, so we're good. All right, and then 18 is the one we're going to do last. Remember, you're not allowed to use a calculator, so when we are working with the natural number e, you will leave your answer in terms of e. First, let's condense the left side. Natural log of something plus natural log of something would just be natural log of the product. 3x times 2 is equal to the right side of the equation. Let's simplify this product. Natural log of negative 6x is equal to 5. What is the base of the natural log? It's the natural number e. So you're actually going to raise each side of the equation into that power where the base of that power is e, the base of your log. So I'm going to put e to the power of something is equal to e to the power of something. E to the power of the left side of the equation, so ln negative 6x, and e to the power of the right side, which is 5. E to the power of ln of something is simply that something, right? Because e is the same base as the base of natural log, okay? So the natural number is the base for the natural log. So what we have is whatever you're taking the natural log of. Your argument is what's left on the left side. Negative 6x is equal to e to the power of 5. E to the power of 5 cannot be simplified any further, so leave it as e to the power of 5. And your answer is x equals negative e to the power of 5 over 6. Or e to the power of 5 over negative 6. Either way, it's